All right, we shall continue with our lesson for this week. So for part 3, we are going to do integration by parts. This is another strategy in performing integration if the previous techniques does not or do not work. For example, you may have seen that this cannot be integrated the normal way, or the integration cannot be performed the normal way. Therefore, we are going to use another technique which we call as integration by parts. So integration by parts come in this format. So it's the integral of u times dv is equal to u times v minus the integral of v du. So as of the moment, this may look abstract to you, but as we go on, this will become familiar. So one thing that you have to do here is to find, or from the given, you have to break it into two different parts. One part, you assume it to be your u, and the other part, you assume it as your dv. I repeat, from the given, you break it into two parts. One, assume it to be your u, and the other, assume it to be your dv. Now, to make that task easy, how do you decide which one is your u? So to decide which one is your u, this is the order. This is the order of priority. So from left to right, if you see logarithms, then that becomes your u. Inverse trigonometric, like arcsine, arctangent. Next is algebraic expressions, trigonometric, and last is exponential. So this is the priority. All right. So if you try to look at the given, going back to the given, here we have an algebraic and we have an exponential, which means your u will be the algebraic part. Therefore, we say let u be equal to x. And of course, to get a du, we need to find the derivative of your u. So du with respect to x is equal to 1. And since we're just looking for du, we cross multiply. Therefore, du is equal to 1 dx. Now, once you have decided for your u, the one that remains is your dv. And that's how easy it is the moment you have chosen your u. So here, dv is the remaining e to the x dx. Remember, you have to include this because since this is dv, to reach to v, we need to integrate this. And the integral of e to the x dx will simply be e to the x. Again, just remember this one for you to easily decide what your u and the remaining will be your dv. All right. So once we have these particular values of u and u, v, dv, and du, we just have to put it in this formula or in this form. So here u is x and then dv is ex dx. All right. So this one. All right. So if you try to observe, this goes back to the original. So it's like the integral of the given is equal now to this. So just simply substitute the value of u, the value of v, minus the integral of v du, which in this case v is e to the x, and du was determined to be 1 dx or simply dx. Okay? Therefore, if we are to evaluate this integral, because this is what we're looking for, right? So we simplify the one at the right, finding the integral of this will just give you minus e to the x plus c. So the integral of x e to the x dx is just simply this. Okay? Again, the difficult part is on the decision. Just follow this priority. Let's have another example. How about this one, x squared ln x? So if you try the normal way, try it out on your seats, you might find that this is difficult to integrate using the strategies that we know. Hence, we go for integration by parts. So again, the first step is to choose your u. So this is the given. From the given, choose your u, and the remaining will be the dv. Again, remember how to decide? This is the order of priority. So here we have an algebraic and we have a natural logarithm. According to the priority, we have to prioritize logarithmic first. Hence, our u should be your ln of x. All right? So du over dx, find the derivative to get du. Du over dx is equal to 1 over x plus 1 over x, yeah? Thus, if you want to find for your du is just, so you have to cross multiply this, du is equal to 1 over x dx. Okay, so since this is our u, the remaining x squared dx becomes our dv. Okay, so we find the integral of the dv to get your v, and we get 1/3 x cubed. I suggest you try to separate the numerical part. So that's 1/3 x cubed because we get x cubed over 3. So we can just write it as 1/3 x cubed. Okay, now from here onwards, we just have to substitute. So u dv, integral of u dv. Now your u is ln x, your dv is x squared dx. So you might write this as ln x, x squared dx. That's totally fine. But if you want to be consistent with the given, maybe you can just simply arrange it, writing x squared first, then ln x dx, so that we could be consistent with the given. Okay? That's why I'm having this in blue for you to know that this is your u and the black is your dv. We just arranged it. So substitute the rest to the remaining functions. So u here, this is your v minus the integral of your v times du. Remember, we already have found your du. Okay, so this is the given, the original given. Therefore, we just simplify this because the integral of the given is equal to the right-hand side. So when we simplify this, this now becomes 1/3. We put 1/3 outside. X cubed and 1 over x can be simplified as such. Continue to simplify. Thus, you will get this function, and therefore, this is now the integral of x squared ln x dx. And that is how to use integration by parts. Now, this is your time to check and apply the rules or the techniques in integration in all 3 examples. You may pause this video and then try to answer, and then after which check your answers. So there are answers, okay, which will be shown. Thank you, and please proceed to part 4 once you are done with this.